and your presentation.
The second one.
And let's share the screen here. Now it should work. You have to move it over here. Okay.
Sure.
So the phone is yours. Okay.
Works. Yeah. Okay. Thank you, everybody, for having me here. I'm going to talk about our recent results on remote sensing of local dust events over the Canadian Arctic archipelago. This is a similar presentation was made in AGU fall conference in Washington, but that presentation was a poster presentation, and new findings was made since that conference. Just to do not waste the time, this is a boilerplate for everybody. You know the impact of dust and local dust. Just I should mention that there are sparsity of measurements in the Canadian Arctic archipelago, and that our objective is to better understand and characterize the optical and macrophysical properties of high latitude dust in Canadian Arctic. Okay, where is the Canadian Arctic archipelago? The Canadian Arctic archipelago is located in the Arctic region of Canada, extending from the northern shores of mainland to North Poles. It approximately includes 36,000 islands, much of them covered by ice and snow for much of the year. Here is the Eureka region that we are going to focus on that. Eureka region is located in around 80° north, and we have Pearl Observatory in there that is included of two measurement sites. Here you can see the Pearl Observatory location that is shown by the red star, and its geographical context on the Ellesmere Island. This high Arctic observatory is a major optical and microphysical data sets of aerosol and clouds in the high Arctic. This observatory has two main stations: Opal at 10 meter above sea level, and Ridge Lab at 615 meter above sea level. So comparing the optical measurements at these two sites give us some things about the dust events happening the low altitude between those two elevations. Here, actually, the AHSRL measurements or LiDAR measurements have been performed in Opal Station from 2005 to 2010. The figure on the top left hand shows the backscatter profiles blinking with the volumetric depolarization ratio, which is a big picture from surface to 15 kilometers. But we are going to focus on the low altitude dust events. So we see the figure on the down left hand shows the LiDAR, the backscatter profiles blinking with the depolarization ratio from surface to 615 meters. We applied an event-based an event classification based on the depolarization ratio. So we have the figure and on the at the right. That this figure give us the coarse mode LiDAR optical depths based on the depolarization ratio, which is small for fine mode particles and large for coarse mode particles. We compared the LiDAR optical depths with the coarse mode optical depths from aeronet measurements in both OPAL and HERA stations. As you see here in the figure, the top right, you see there is a good correlation between the coarse mode optical depths from LiDAR and coarse mode optical depths from aeronet at OPAL. And the coarse mode optical depths from Ridge Lab station shows virtually no correlation. So it gives us that, it says that we are actually looking on a kind of dust at the low altitude. This is another event on the 21st August 2018. Here you can see the optical and macrophysical analysis of a dust event. The figure A shows the aeronet inversion particle size distributions, and the figure B shows the APS particle size distribution. APS is an aerodynamic particle sizer, which is a macrophysical instrument, and which is another independent sources of data. And the figure C shows the coarse mode optical LiDAR optical depths and coarse mode aerosol optical depths from aeronet time series. The colorful triangles shows the approximate time of aeronet and APS measurements. As you see here, there is a similar bumps in the aeronet inversion PST and APS PST around 1.3 micrometer, and as well as a coherent rise between the coarse mode optical depths and LiDAR coarse mode volume concentration after 2030. The figure on top right also shows a 3D high frequency time series of APS particle size distribution through the dust events. Here is a blinking satellite Sentinel-2A and Sentinel-2B image of the previous slide of the previous event on 21st August 2018. As you see here, in the plumes in the Eureka sounds look like dust plumes. The wind speed and the wind direction trajectories shows seems that the dust is coming from somewhere around Ridge Lab towards Opal Station, and that might be the reason that we have the rise in the coarse mode volume concentration and coarse mode aerosol optical depths after 2030. Here, there is another dust event on 8 September 2020. Here is a MODIS, aqua MODIS color imagery blinking with the coarse mode aerosol optical depths derived from the AOD product, MODIS products. As you see here again, the coarse mode optical depths captures the location of the dust on MODIS color imagery. We also had some other investigation, dust plume investigation on the other parts of the Canadian Arctic archipelago. Here you see here is the Prince of Wales Island, and this is Victoria Island in the southern part of the Canadian Arctic. You can see the MODIS Terra image of that that area on 26 September, I think 2018. It's behind the. And you see that again the coarse mode optical depths from MODIS products captures the location of the dust plume, which is coming from, which is flowing from the Prince of Wales Island toward Victoria Island. We also use the data from MISR imagery. As you know, the stereoscopic nature of the MISR imageries enable us to extract the dust plume height and dust plume velocity. Here at the left, you can see that the dust plume velocity on top and dust plume height at bottom for a sample tracking of that plume. And the histogram here shows that the wind corrected height of the plume is around 500 meters. The source of that dust plume seems to be the 20-kilometer wide desert-like region in Prince of Wales Island. That is from Google Earth imagery. Here is another dust region in southern shore of the Banks Island in southern part of the Canadian Arctic archipelago. Again, you see a blinking image of Terra MODIS imagery and the coarse mode aerosol optical depths derived from AOD product of MODIS on 1st October 2018. Again, you see the coarse mode optical depths corresponds with the plume region. There is a map on all the slides that shows the location of opal, which is the red star, and the location of that dust plume, which is the green star. So you can see the geographical context of the region. Here is a higher resolution imagery of the previous event of the Banks Island. This is the Sentinel-2B image of the region. The top left is the original Sentinel-2 image surrounded by the zoomed image of different sources of dust. As you can see here, there is a different. We can see different sources of dust on that region, which are showed by the purple arrows. The things that we can understand here is that the plumes are the thin plumes are have continuity from the land over the water, and also we can say that we are actually looking at the real dust plumes over the water because of this continuity from the land. Here is another dust event on 13 September 2017, I think. It's on Elf Ringness Island, at the middle of the Canadian Arctic archipelago. You can see the location with the green star. Again, the coarse mode optical depths blinking with the colorful MODIS imagery shows the coarse mode optical depth over the water, and also the calculated aerosol optical depths over snow, which is calculated using the reflectance of that brown region, light brown region encircled with that blue dashed line, divided by the reflectance of the clear region of snow and ice north of that region. This is an ad hoc attempt at the new AOD extraction technique. The important things here is that the continuity of the AOD over the snow is like what we see over the water from dark target algorithm of MODIS imagery. Here again, we used the data from MISR imagery. Again, we just extracted the plume height for two sampling track of the plume, one over water and one over the snow. And just we wanted to compare the plume height. And as we see at the bottom, we see both plumes shows the height of around 500 meters. And both seems to be so from the same source from the Rington Islands. Also, during our investigation, our dust plumes investigation, we also saw kind of footprints of deposited dust over the different regions. This is two examples of 14 June 2016, close to Opal Station. You see the footprints of dust on the ice, and the right one is also another example of this region, very close to Opal region on the snow. These kind of deposited dust needs to be more investigated because to be just separated with airborne dust. So we need to take a look on different imagery day by day, or just use the different independent instruments, or like let's take a look at the MISR imageries to see if the plumes has a height or not, to be concluded that the footprints are kind of deposited dust or not. Also, we can compare the brightness temperature difference from MODIS imageries, and as we know, for the deposited dust, it should be a kind of a extreme negative value, and for the snow and ice, it should be positive. Thank you so much for listening to my presentation. I should add, we also has published a paper around 2 months ago that Norm is the first co-author of this paper. I would ask Norm if he wants to add some comments on this new paper, and then we can go for the question section. Norm, if you're available, you can go ahead.
Oh, just quickly, it's a statement that very often remote sensing of dust over the Arctic is confused with other components such as cloud or diamond dust. It's just a general comment, and it seems to happen pretty frequently. So we thought it was worth a comment. Thanks, Ali.
You're welcome.
So thank you very much for this interesting presentation. Do we have any questions here in the room? Yes, there is a question from Marianne.
Okay, so really great talk.
Thanks so much.
What do you expect from the new satellite missions like EUMETSAT, you know, MTG or EPS second generation, or even the NASA satellite missions in the near future?
Yeah.
Which parameters or which data you should?
Yeah. Generally, as much as we have data imagery, so we might have been able to have more results, but the problem or the situation in the Arctic is that the local dust plumes that we see are not that much larger scale to be seen in very low resolution imagery like that, or they happen. They also the clouds in the Arctic are the main problem for our dust investigation that really limit our investigations. But I can say, as much as data we have, we just need to investigate. We cannot say no, we cannot use those kind of data. So we hope we can use those data. But since now, the most how to say reliable data, satellite data is MODIS, aerosol optical depths or higher resolution like Sentinel imagery that have a couple of images of the Arctic region during different days. But yeah, but generally the potential of satellite remote sensing on dust optical depth detectability is how to say, it's worse than the ground-based measurements. So satellite-based remote sensing in the Arctic region has worse capability in dust optical depth detectability compared to ground-based measurements. You're welcome.
So Santiago Gasso has the next question. Can you please spell it?
Yeah, can you hear me?
Yes.
Oh, okay. Hey, really nice talk. All those case studies you have there. Good eye. Two questions. First of all, in one case, let me see. I think in the case for 14 September 2014, you showed an example of dust over snow, and you showed aerosol optical depths reported over snow. Where is that product coming from?
Could you mean this slide, and Santiago?
Let's see. It's let me see. Is the case and maybe
Okay, it's number 15, slide 15.
Yeah, it's for September 13th.
Yeah. This
The previous one, I think.
Google.
Number 15. Number 15. Yeah.
Just,
Yeah. So there you're reporting aerosol optical depth over snow, which is something it's a product I'm not familiar with.
Yeah, as I mentioned, this is an ad hoc attempt, Santiago. It is a kind of temporary just for this situation. We've just wondered if we can have kind of, if we can extract kind of aerosol optical depths. I can just let me, sorry.
So when you mean ad hoc, is this you did the retrieval or?
Yeah, this is you see, this is the detailed things about that dust extraction. So in this region that is green region, which is aerosol, which is the snow region. Actually, this region, if you see my finger, I don't know. This region is an island, so we ignored this region and we just focus on this snow region. So we have the over the snow dust region, the reflectance, and also here we consider that this is a pure, clear snow north of the region. So we do using this. No,
that's great. It's but I understand it's not a retrieval. It's something that
exactly. It's just an attempt to see what if what we derive is something similar to what we see above the water or no. And hope fortunately those values, the extracted AOD values was kind of comparable with the optical depths over the ocean.
So I have a quick comment because this is relevant to everybody, I think. I know the Canadian Space Agency has just announced they're going to have a network of satellites to monitor fires and smoke. But because there are going to be more satellites looking at that, you can also start to look at dust. So and because they are polar, they will be going everywhere, like Iceland and other ice. So are you familiar with this new network of satellites? It's really new.
If you mean the Hawk mission that they are gonna, I have some news about that. I think the atmospheric dust or aerosol measurements are also included in that mission. So that's a very good news for remote sensing community in working on high latitude dust. I think Norm can have more comments on that.
Can I just interrupt a second? I'm not sure that's what Santiago means. You're talking about some network, constellation of satellites. Is that right, Santiago?
Yeah, I learned it through social media, of course, because that's where you get the news from now. Yeah, but I can retrieve that. I can follow up privately. I mean, it's just I'm excited that a country with investment in high latitudes like Canada is becoming interested in remote sensing, focusing on the high latitude. And in this case, is smoke, but it can be used for dust too. So
Yeah, the Hawk mission is going to focus on profiles of water vapor, aerosols, and ice crystals.
I see. I
And
see.
it'll be polar orbiting, so it's that'll mean, of course, a lot of Arctic views.
Okay, let me see. I'm gonna share on the link a piece of news that shares, that reports this. Yeah, so it's a piece of news. Yeah. Anyways,
Yeah. Oh, sorry.
I'm sorry, we have to move to the next speaker now, and there is still a question from Philip. So if it's a short question, can you just write it to the chat, and Ali will answer on the chat. And we
Sure.
can also continue this discussion after last speaker, okay? I think they heard me. Yes, so please, Philip, if you could write a question into the chat, and we can continue these discussions after the last speaker now. Thank you, and thank you, Ali, again.
You're welcome.
And, next speaker actually will continue talking about the Northern Canadian region, and it's Aldona Blacek. Hopefully, it's a correct pronunciation of your surname. So feel free to share, and it's a pleasure to have you with us today.
Okay, so can you hear me okay?
Very well.
Great. Well, thanks so much for having me. It's really nice to meet this group. Oh, I'm going to put my timer on just so I'm respectful of that. So this is work that is currently in ACPD that was led by Ian Ashpole, who was a postdoctoral fellow with me. We live and work in St. Mary's University, which is in Halifax and in Canada. And the title is Satellite-Based Evidence of Dust Emissions over Northern Canada. So again, not to take too much time with the introduction, we know dust is important, comes from dry areas, it might be increasing, and that it could be a third of the dust loadings in the Arctic, so important locally. I just want to stress that in situ research is exceedingly hard in the Arctic. We know that there's just a handful of source areas documented in Canada's north. At the same time, we know that there's got to be many more. And, based on, for example, preferential dust source area maps, I remember looking at those with Ina Tegan, back in 2003. So we know that dust is sourced in the north. So what we did in our study, the summary of our method is that we looked for and tabulated extreme dust loadings in high-res satellite data over 20 years over land. And the logic for this was where there's smoke, there's fire, or where there are recurring extreme dust events over 20 years, there's potentially an active dust source there. And also guiding this is, a phrase I like, trust but verify what the satellite data tell us, understanding that there are biases and limitations. So this saying is often credited to Ronald Reagan, but he actually got it from the Russians in the Cold War. It was "Dovrye no provrye." It rhymes in Russian. Anyways, kind of my credo as a scientist. So the details of our method start with L2 Modus deep plume aerosol products at 10 kilometers, and then calculate from these a dust optical depth in two ways. And so, there's a method published by Pu and Janu in 2016 and one by Baddock et al. In 2016 as well. I might have these dates wrong. They basically derive a DOD from an optical depth with an empirical function of the angstrom exponent, and if the single scatter albedo is less than 1. This other one is a little bit more heavy-handed, and I won't show results from that one in the talk, but they're in the paper. So both of these products look for coarse dust modes, and that's great because coarse particles are the ones that are going to remain close to source regions, and they're the ones that dominate the mass and volume distributions at the place of emission. Now, something we do in the study is to use all QA levels, and that's to avoid basically losing all the data. And that is following the recommendation by Baddock et al., but only in doing dust source studies. So you wouldn't necessarily do this if you were trying to create a field of DoD for comparison with models and model validation. And then we look for, or calculate rather, the frequency of occurrence of extreme dust events. And our threshold was 0.5 for DoD, which will register in satellite data. And that's something that, is in Norm's paper on dust confusion from remote sensing. Then finally, we regrid this to 0.1 degrees to create a L3 product that's optimized for this study. So the results are as follows. So this is frequency of occurrence of how much times DoD was greater than 0.5. This is over 20 years. So, there's up to 100 events over 20 years. So 5 events a year would be an average. And then this is the same data, but represented as a relative frequency. So taking into account the number of observations. So it's spanning from, nothing to about 50%, which is a little bit high for an extreme event. But this is also taking into consideration that the number of events is really, really low. So the further north you go, the less observations you get for a couple different reasons. Just like, in high mountains, you get low events, and we'll come back to observations around high mountains as well. Okay, so it looks like these are the places where extreme dust events occur, not on a regular basis, but in a tally of 20 years of observations. They stand out. Just a little note about the effect of these DoD thresholds and the quality flags. So this is the same thing as I just showed. This is just zoomed in. Each of these bottom panels are zoom-ins. So this is DoD greater than half, frequency of occurrence, all quality flags. And if you go for best estimate, you literally decimate your data set from, about 100 events to about 14 events. Although some dust emitting places remain out there. You can achieve the same effect by asking for an even more extreme event. So for DoD greater than 1, which was like at the top of the scale for some of those dust over snow things that Ali was showing in the previous talk, right next to the sources. Okay, so what's the seasonal dependence of this FOO and the total number of observations? And so basically, this is the absolute frequency, a relative frequency, and the number of observations that go into making these plots. And we see that, our data, our maps in the end are driven by June, July, August, which is when we have observations because it's daytime and it's the least problems in retrievals over snow and ice. There's a little bit of data in the shoulder season and no data in the dark and snow and ice. Okay, so the main evaluation of what we did for whether or not, this is real was actually a comparison to the source intensity maps compiled by Anna Vukovic, the global sand dust storm base map, source-based map. And we did this for July because in April and October, there's not much going on in that map. And so, this map, it's well known that there's potential for dust emission in July in all these regions with the right wind conditions. So this figure here is a logical figure. The colors are logicals. This is source intensity, and wherever the frequency of occurrence of these extreme DoDs is less than 10%, so not much is happening, and the source intensity map is also less than half. So anything that's white is that the map says it shouldn't be emitting, and our data says it's not emitting. Red areas are where the relative frequency of extreme events is more than 10%, and the source map is greater than half. So that indicates agreement between the map and our results. And then the blue and the green areas are areas of under emitting with respect to the source map or over emitting with respect to the source map. So we have a lot of green regions, which are regions of emitting more, perhaps. Although, you know, we can argue about these thresholds, and this is, you know, this is one way to look at it. So we put a box around this, and that's what we call the Canadian Arctic dust belt, from about 70 to 80 north, 85 to 125, roughly. Okay, so when you look at these green areas, so the over-emitting areas, so there's dust emitting there, but it's not in the source map. And we looked more closely at these two places that were fairly confined and fairly granular. One is in the Mackenzie Mountains, and it looks like this in the visible, and it has average wind speeds of more than 8. And one is at the border of Labrador and Quebec, and it's got even higher wind speeds. It's an exposed plateau. These are not my words. These are words that, you know, I got from geologists that are, you know, we talked to geologists who actually were in our department, oddly enough, and have done field work in these areas and said, yeah, there's a lot of unconsolidated fine glacial sand with scarce vegetation, very little soil to suppress dust mobilization. Yeah, so this is an exposed windy plateau. It doesn't look that amazing in visible imagery, but it shows up as a dust source in our stuff. Okay, so about catching dust. So if you look at our map of source intensity, frequent extreme events, here's the two sources that I was just talking about. And here's sort of two stations that had a fair bit of data. And Eureka's up here. And so Kluane Lake we looked at because it's instrumented and it's been placed downwind of a dust source. But the frequency of events is very low there. It's less than 25. And this is really difficult terrain for a satellite. So this is topography, and this is Kluane Lake right here. And here are the vectors on these maps are average winds from ERA, 925 hectopascals, 850 and 700. So although the station is, you know, downwind of sources, and we understand it's complicated with valley flows versus synoptic flows, it's nice work by Daniel on that. We should be getting some data, and perhaps we are getting some extreme events, but it's kind of hard to tell because the observations are sparse. So the other one, it's Resolute Bay here that it's going to switch to. And Resolute Bay has less of a topography problem, and the station is here, but essentially it's upwind of what our data calls a potential dust source, where the frequency of events that are quite dusty is high, but like this station isn't positioned in a way to be able to ever catch that because it's upwind of the sources. Okay, so one of the last couple of things to show is there a temporal change in the frequency of occurrence of these extreme events if you average it over a large region? And so we looked at, this is the frequency of AOD over 20 years, and there isn't a trend going on here. And the green and the blue lines are the frequency of occurrence of DOD events. So you could squint and say less here, maybe a little bit more there. That's with Pujanu's method. And this is the blue one is for Barak 2016. You know, there seems to be a fairly dusty year when you look on the average of FOO in those spatial maps. But it's a pretty faint signal. The other thing we did was look at vertical dust type distribution from Calypso. So this is Calliope aerosol type equals dust, just counted as occurring in June, July, August, all the available data at the time of analysis. So we took their L3 data and we averaged it between 60 and 80 north, which is a huge swath. I mean, this shows median elevation in that average. And this shows, you know, what we're calling the longitude range of what we're calling the dust belt, Canadian Arctic dust belt as well. And so there's some evidence of like homogenized dust above the Arctic and east of Greenland and above the ice sheets, which we could talk about that. But forgive me, but I screen capped a couple really interesting plots from yesterday when Aaron Rafe was talking about how there's 7-day back trajectories showing no link between INP and local source regions. It was in a different season, but then we had Ross Herbert showing that, you know, dust is pretty aged. These are bigger particles. Bigger particles would fall out faster, but still, I mean, this is kind of a consistent picture of homogenized dust that, you know, doesn't contradict these. And then this morning, you know, I don't know much about anything about dust emissions like here or where this could be, you know, coming from. But this morning there was a really nice animation of the dream dust load, you know, with katabatic flows mobilizing dust and I guess pushing it out over the water, and you've got the Icelandic sources. So maybe this is real too. I'm happy to talk about that. And yeah, just to wrap up. So yeah, we did this. It compares reasonably well with the source map. We identified a couple new sources and said, you know, it would be nice to measure in there clearly, see what's going on up there. Catching dust is hard, and there's some evidence for increasing activity of dust sources in time, and some evidence of homogenized dust signals in CalUp data. Okay, thanks. Wait a second. Hang on a second.
So thank you for this really interesting talk. And
Okay, I have my sound back. Sorry.
many questions.
Sorry, I wasn't able to hear anything, but now I can.
Yeah, so thank you for really interesting talk. And there are obviously many questions. So let's start with that. So we have some questions here in the room first.
Yeah, hi, thanks a lot for the very interesting talk here. I have a question. It's a little bit, it's not off topic, but then again, a little bit. Right in the lower right corner of the Canadian Dust Belt, that is the location where the Mary River iron mine is operating, right? With, I think they mine out approximately 6 million tons ore a year that is then transported by haul trucks up to the pond inlet. And I was just curious, yeah, it's right about where you have your marker now. Is that something that you think could be detected using these techniques, or are they, you know, too transient? Would you think?
Well, I think that if dust in that area will cross over 0.5, then it should be detected. Yeah, could look at that.
Thanks.
And there is, thank you. So there is a next question in the room.
Yes, you want to go on? Okay, thank you so much for your nice and interesting results. I just wanted to, I have a lot of questions, but I just wanted to talk about the Kuluani Lake region, that the map that you showed if you go to that slide. I'm wondering if these results over the Kuluani Lake is also from your method. I mean, comparing the DB AODs. Are you these maps are creating from DB algorithm?
They are, yes.
Okay.
Yes.
And the green map, the green color map down there shows the I think the light green is the lake.
Yeah.
I think. Okay.
Well, yeah, I mean, so the lake is
Yeah, I'm wondering.
sea level, sure.
I had a lot of. I mean, we had a campaign in there in 2020, 2019, I think.
Yeah.
And we had some ground measurements there. But anyway, at least how did you extract the AOD over the lake from DB? Because the lake is dark and DB is better to use around land.
So we took the product, and if the product had the data in it, then it went into
exactly.
our analysis. And as I said, I mean, it's taking all the quality flags, right? So it's taking data that you might reject for an
Exactly. I just wanted to mention,
quantitative analysis of AOD.
yeah, I think that the reason that you have data over the water from DB is not that we just have data. It's kind of uncertainty of DB algorithm that we cannot they cannot have trust on them. And
Sure.
also the problem you know about the problem that DB algorithm has over the bright surfaces like what we have in Arctic region. It's better to use on Saharan dust region like that, but for Arctic region, I'm not sure the results are so reliable.
Well, yeah, I mean, the Arctic Sahara is also super bright, right? So as long as you're looking at the Arctic region and its land and the ice has receded, you know, you should be in a better position. And in any case, we're not doing quantitative AOD. We're doing source location verification of source activity, if you will. Yeah, so those are good points. Sure.
And just a quick one. If you go to your slide 3, please.
I don't know which one. I don't have numbers on.
Just this one. You know, what do you think about comparison between the first plot and the second one?
Yeah, so I mean, in your work with results at Eureka, I think you say that relative frequency of these extreme events is like 11%, right? And that, you know, you get that with one station. And I'm not saying anything bad about that. There's no stations really up there, right? So it's where it hits a relative frequency of about 50%. That's obviously no longer an extreme event, because extreme events are not 50% of the time. So that is a little bit artifactual. And, you know, then you look at the number of observations and you go, oh, okay, but I'm in low number statistics right now. So I'm not going to put all my faith in this that, you know, yeah. Because what this is saying is when there are observations in this region, half the time they're extreme. I agree. Yeah, we're aware of that.
But I think, for example, the dust plumes in the United States are disappeared in the second figure. But
Yes.
You still have maybe more than 15% of your results shows that there is a dust events in Arctic.
Yes, but these plumes disappear because there's, you know, 2,000 plus 3,000 observations over here, and so they disappear in a relative sense. And you know, it's an agricultural region. It's going to be mixed dust and aerosols, and it's not howling winds of the north type thing. So.
Okay, thank you so much. I just recommend, for example, for your next presentation, just show a couple of dust events or a kind of event base that is comparable with your results here. Thank you.
Yeah, that's really great work that you're doing. So we're happy that you're doing that.
Excellent. And there is one quick question in the room, or no? Okay, so is there any question online?
Oh, Santiago's asking, can I tell if the transition months of late summer, early fall are a period of higher activity? I think the answer to that is no, because of the seasonal breakdown of this. Well, it depends on how you slice it. So, I mean, this is the absolute frequencies here in the transition seasons. So they're lower, and in the summer they're higher. Yeah.
Yeah, that's something to explore, I think, because it goes, I mean, the physical explanation why you have more activity in the late summer, early fall is because you have, at least in glacier rivers, you have less melt and you have more bias. So it's just trying to, you know, what I'm pointing out is just trying to
okay.
Observations with the physical explanation or something.
Yeah, so we could break this up and see whether perhaps all of this is September and none of it is May. Yeah, that's a good point.
Yeah.
Yeah, that's a good point.
Okay. Actually, I think there is the paper from John Crucius on the variability from the Copper River over time. So you might find it in that paper. I think it's, yeah, early autumn. Yeah.
Great.
All right, thank you very much. And next speaker, thank you. And next speaker is Agnes Panta from Germany. And he will talk about in situ aerosol measurements and observation. And he's one of those who spent months in Icelandic desert. So he knows exactly how is it to be exposed to dust. Can you just open it yourself? Or?
Yes. Will I put it here or
Yeah, it's maybe just here,
like here? This? Or does it-
go off like this way. Or maybe to your pocket.
okay. Yeah.
They look better. If it works like this. No, this you are correct. Sorry for that. Yeah, because you have to push it here.
I see.
Now it's easy.
Okay.
And we have to share in Zoom. Here, screen, there, or how you
Yeah,
wish.
sure. I think
And
oh, this one. Yeah.
time.
Once more.
Yes, and then hopefully this one will disappear.
Yeah.
Thank you.
So good afternoon or good morning to all the viewers online. My name is Agnes Panta, and today I'll be talking about in situ aerosol measurements and observations. So changing perspective a little bit from satellite and model-based results that you have seen. So it's going to be a very general talk that I'll give. Basically, I'll talk about some of the aerosol measurement methods. So I'm involved with a Palas company. Basically, one of the business is producing optical particle counters. And this is what I'll be showing. And also some of the results that we got in this campaign. So brief introduction about the two projects that I was involved in, Fragment and Hilda. And both of these projects were had the focus on dust emission in source regions. So going in the source regions of Saharan and high latitude in Iceland to study the dust emission process and try to understand the dependencies of emission on the conditions. With Fragments focus on the physics of dust emission, as well as soil properties and local scale meteorology, whereas Hilda focused more on the high latitude dust and its exports from Iceland. So we all know this plot, basically showing that dust, even though it's generated in the source region, it's not just staying there. It travels all over the globe and has implications not only for locally but also on a global scale. And you see the major pathways, even though it is even the Icelandic dust, it is not previously was not shown in this kind of plots, but now it is gaining more and more tractions. And you also see the Iceland high latitude regions in global dust cycle. So here what you see is from one of these in situ measurement campaigns. So we had a lot of instruments with various objectives. The two major instruments that I'll be talking about are the FIDAS, which is here. This is also one of the optical particle counters, and the WALAS, basically measuring the size, particle size from 0.1 micrometers up to, so you can always choose up to what diameter you want to use. So basically it's going from 0.1 to 100 micrometers. You also have the cloud droplet analyzer that is mainly used to have
measurements of giant and coarse dust particles, because these are also very relevant these days, because most of the climate models, they don't actually, they're not actually taking into account these giant mode particles. So therefore, it's very important also to measure the coarse and giant particles. Also on the other type of sampling that we did in these campaigns was impactor samplers and deposition plate samplers. This was mainly for offline characterization of aerosols, which was part of the major work that I did during my time as a PhD student, basically collecting them at these source regions and analyzing them using electron microscopy. So quickly on the results. So here, what you see is the comparison plot between Iceland and Morocco. So as I said, we had a similar experimental setup in both of these locations. And this is coming from the optical particle counters that we used. So what you see here is the normalized mass distribution against diameter. So we see that, Icelandic dust is a lot coarser compared to Saharan dust. And this is quite an interesting result, I would say, because these kind of results right at the source, we don't have so many. And using the same setup, we can clearly see that the size, we have a lot of coarse particles present in the high latitude, at least in Dingusendur region. Or the high, So in Iceland, we did this field campaign in Dingusendur, which was quite active during our measurement period. We had a lot of dust storms. Also, what you see here is another size distribution plot, but this time it is from the deposition plate sampler. So basically what you see is the number size distribution again, which is based on the particles collected on deposition plate and with an average exposure period of 1 day. And here also you can clearly see that with the black one, the Icelandic dust has a lot more coarser particles in them compared to mid-latitude dust like Morocco and Jordan. And also, if you look in the submicron range, we have this decrease of number concentrations, which is also what we see with online measurements, meaning optical particle counters measurements. So this kind of corroborates with that. And this is where I was in contact with Pavla, and she is involved in CAMP's NCP Iceland project, which is basically trying to establish 3 permanent and 1 temporary dust measurement stations. And so I got in contact with Pavla, and we sort of started this discussion of having one of our optical particle counters for this project. And I thought it would be great to bring this instrument here and place it here, and to show her that the instrument, we could use it in challenging conditions of Iceland. So just a brief description of this device, which I have it here. So if you're interested, I can also show it later. It's called AQ Guard 1000, basically air quality guard. So this is also optical particle counter with a range of 0.175 to 20 microns. And we have 64 channel sizes, and it has time resolution of 1 minute. Basically, it's a moving average 1 minute, and it is certified by MCERTS as well for PM2.5 and PM10 measurements. And we had this instrument was used a couple of years ago in the in this volcanic region to look at the impacts of volcano on the aerosol size distribution. And so we placed almost 9 aggregates around the area to have information on the spatial variability of the aerosols. And what we found, so here you see on the gray color is the size distribution of volcanic ash, which you clearly see that it is dominated by coarse particles. And with the orange, it's the Saharan dust. You see the PM values are relatively similar, but the amount of coarse particles with volcanic dust is much higher compared to PM10. So this clearly shows how important it is to do these kind of measurements. But also what is interesting is for volcanic ash, you also see this number concentration is quite higher in the lower fraction. So there is also a dominance of the submicron particles in volcanic aerosols, so probably sulfates. So I'll talk a little bit about how the data from the device itself, it can be, because one of Pavla's concern was also how to get this device into the CAM's web page, or how to get it in real time. So all of the instruments that we have, it can be directly, the data can directly come into the server, and it can be connected via API to any of the platforms. So that's a great thing. And like we saw in previous presentation about all the possibilities that was in the new homepage of Icelandic Air, or Iceland.is, this website. So we have pretty similar features for all of our devices as well. So all the visualization and analysis can be already seen. So it's very useful to have a very quick look of all the numbers distribution, mass size distribution, and it can be, you can also look at the windrows, for example, where the dust is coming from, and was there any effects of the wind direction on the aerosol concentration as well. So this is all really very helpful and really very easy to get the information. So just a summary of my talk. We see that there were a couple of different points. The first one was, we clearly see that when we look about freshly emitted dust at 2 of the major source regions, we see that high latitude and in Iceland, for example, it is much coarser compared to the low latitude Icelandic, for example. And we also see that the particle size distribution of different aerosols, for example, volcanic or Saharan or normal ambient air, they're completely different. And if we know the size distribution, then we can better assign it to a specific source. And we're very excited about this potential collaboration with the CAM's NCP project, and we'll see how we can, how good the instrument performs in these harsh conditions, because it is also quite new to us. And yeah, also you're open to check the My Atmosphere website. It's free for everyone to use. You just need to log in. You just need to create an account and log in, and you can easily have a look at various air monitoring stations that are available all over the world as well. And you can add Palace instruments if you have one. Yeah. So with that, I'll be very happy to take questions, and yeah, thank you for listening.
Thank you very much, Agnes, because there are so few papers showing these particle size distributions
Yeah.
for Iceland, so it's extremely valuable.
Yes,
You've
I-
mentioned in the new Sandor.
Yeah.
That might be different for the southern Iceland deserts because
Yes.
they have slightly different, like the mother soil, mother material.
Yes, the parent, it definitely depends on the parent soil composition as
Yeah,
well. But it's very challenging to do these kind of intensive measurements across many parts of the region because
Yeah, it was tough, I
Yeah.
remember, but we survived.
yes.
Are there any questions for Agnes in the room here? So, yeah,
I
Shall
guess
I
not.
would have one for this. So when you get, so you said the particle size distribution is 20 micrometer, the largest for the instrument can measure.
Yes,
So I
for
think-
the AQ guard, yes.
Yeah, because I think if we get, so that's the total PSP.
Yes,
Yeah, because when we get those measurements, and it's also known from the medical studies that also larger particles than microns are found in lungs of dead people.
Yeah.
So, but
yeah.
also it would actually explain why do we have maybe only by the calculations of his total amount of dust transported from Iceland is in terms maybe 10 times larger than what the models predict. So, I mean,
Yeah.
the FlexPar-based models. So that would be
Yes.
really nice to have also kind of evidence on that from the in situ measurements, because we might have maybe, yeah, I mean, the maximum concentration is 100,000
Yeah.
micrograms. So what happens when you go over? Do you have to over calibrate?
Um,
Is it gonna be set, or you don't know yet?
no, probably we might have to clean the sensor, but it is quite an easy task. I mean, if it is too much of dust,
Mhm.
there might be the optics gets a bit dirty, and then it's not able to characterize the size distribution correctly. So you might need to clean the sensors.
Mhm.
But yeah.
Let's see.
Yeah.
I'm very curious. Thank
Yeah.
you very much. And there are questions here in the chat, so feel free, please, to raise the question. Just asking. Yeah, so Agnes and Santiago, can you repeat your question? Also for the listeners here in the room. Maybe he doesn't hear me because I don't have the microphone.
No. Could you go to slide 10? Do you want for
Or
this?
can you say?
Hi, Santiago. Could you please ask the question for everyone to listen? I guess. Or could you also put, please, Pavla,
Okay,
slide
so-
10?
Oh,
Because-
yeah.
Yeah.
No, just I mean, Conrad already answered the question. Yeah, I mean, when you're comparing showing size distributions like that, just I was wondering the distance to the source. I mean, in slide 10, you're saying dust from Sahara tends to be less coarse than Iceland. So I just wonder if you accounted for distance to the source. Slide.
How far was the
Yes.
from the source of, if it was
It-
on the source or from the source?
So, okay. You mean the radius in some way?
Well,
far?
I mean, no, here you're showing that Iceland has more volume or more mass in the
Yes.
course than Morocco. That's fine, but it depends, really depends on the distance where the sensor is located. So, but Conrad said that in both cases the distance is similar. So that's okay.
Yes, because in both of these locations we kind of were really in the source, so they were kind of comparable in terms of the location.
Yeah.
Yeah.
Are there any more questions here in the main? I think so. Thank you very much,
Thank you.
Anisha. And now, so now is
officially concluded the session on remote sensing and in situ measurements. And I will take advantage that Alexander Baklanov is here with us in person, and he has attended many important meetings, so he will be so nice and tell us what is happening in the higher circles about high latitude dust. Thank you.
And you probably need a microphone. I'm not sure if they heard me now. So, yeah, sorry. Is it this one?
No, this one.
And let's share the screen. Presentation mode.
What are you gonna do with it?
And hopefully this one is different.
It's okay.
Yeah. When you just go down. Yeah.
Now, as Paul asked me to give some overview of big international events, and I'll just give some overview of where I was involved, and of course, with relation to our high latitude dust problems. First of all, I'll start probably from initiative which was started about 5 years ago, I think from 2020, arena for gap analysis of existing collaboration for Arctic research. And it was initiated by Helsinki University and supported by Monaco Prince Albert II Foundation, and involve many different organizations worldwide. And here you can see the not full list of bodies which were involved in this study. It was several events organized, but just last week we had a meeting in Monaco where concluded analysis of existing gaps in climate and Arctic science in general. And here you can see the picture of the participants, and our Finnish colleagues Hanna Lapalainen and Tuka Pete lead this event and organize, and together with Prince Albert, who is in the center of the picture, arranged this meeting, and the discussion was mostly within 8 round table discussion, and you can see here the list of topics. It's very broad, and of course many of them are related to high latitude dust problems, what we discuss here, especially linked with climate. But the most probably relevant, it was table 5, what I co-chair, for research priorities around Arctic air pollution, and was also linked with PACES activity. And here is our table, which was chaired by Steve Arnold from Leeds University, and Kathy Lowe is co-chair, but she was not able to participate. And some guiding questions what we discussed. And this actually round table was linked very much to PACES project, which is one of the IGAC supported networking project for air pollution in the Arctic, climate, environment, and societies. So this the main focus. Just to save time, I will not go into details, but later you can see some questions and
what we discuss and trying to answer. The main priorities what we put in key messages. First of all, characterization of local Arctic pollutant emission sources. We discuss here a lot, and high latitude dust is one of them, and also poorly constrained contribution of potential impact of local emissions on aerosol cloud interactions. It's also one of the issues what very much discussed here, and it is also considered as one of the hot topic for future research. And new, maybe they are also very important, but less for relevant for dust, new particle formation, etc. But shifting natural baseline solution, including dust, this is also one of the trend what was stressed during this arena for gap analysis, and also for modeling challenges. It was also mentioned about new generation models needed for multi-scale and seamless approach, and for airborne transport of local high latitude dust and low latitude dust was especially stressed. And of course, I tried in connection with Oti and Pavla to put some efforts to push our focus for high latitude dust, and it was fully supported and really included. And also for geographical gaps, it was discussed a lot, and also some observation campaigns which could be important to consider, but maybe return later. And for key messages for observation, it was the main actually focus of discussion, and especially PACES requested to analyze vertical structure studies of pollutant distribution, and also main key questions what we discuss and put some addresses for increasing vertical sampling for meteorological variables and aerosol specification and gas forcing, and also aerosol cloud interaction again was considered as one of the hot topic, and again fire and dust influence for especially for long range transport, and also interaction with climate and environment impact, and also near surface and loft profiles was considered as one of the, and more specific focus was on vertical potential platform for routine vertical sampling, different type of observation, including ground-based remote sensors, lidars and ceilometers, etc. And also nice example of cost-benefit, cost-efficient balloon measurements, and also combine it with drone and quadricopters for observation. And also was stressed to return to commercial regional aircraft. Unfortunately, this IAGAS system flights to Arctic and high latitudes are not much involved, and it is also stressed what it would be good to increase involving, and several companies like Lufthansa are deeply involved in that. And high latitude platform for satellite observation, and also nanosatellite, one of the future possibilities considered, and of also community-based monitoring and involving low-cost sensors, and of course also discuss some challenges for satellite limitation and some barriers and stressed what combination of such approach with different observation platform could provide a good start for analysis of such data using artificial intelligence and machine learning approach to build full pictures of. So this for this event, and as Paula asked, I would like also to say a few words about sun and dust storm warning advisory system of WMO. Even now, it is not in my hands. The last 10 years, almost 10 years, I worked and was responsible for that. But now it's Sarah Bassart. So with all questions, please to contact her. And also to Professor Daniel Tong, who is the chairman of the Global Steering Committee. And I suppose most of you well know the SDS WAS, what it's doing, and so we'll not repeat about the mission. And of course, the most important what High Latitude does when we discuss, and thanks to Paula Oti to stress this problem. And in the beginning, WMO, we didn't touch high latitude dust problem at all, mostly focusing only on low latitude. But now it became more and more important. And as I mentioned also in a report of Secretary General of United Nations, high latitude dust was mentioned. And now this network is integrated and welcomed. And WEN is one of the representative in the NAMI node for what is called North Europe, Asia, and North Africa. Yeah. And because it was not easy to establish new node or new center, it was at least as temporal solution was suggested what it will be considered under the NAMI node, one of the directions. But of course, you are welcome to convince for separate section. If like, but I have to say what sometimes Sarah is a bit skeptical to include too many nodes. It is, of course, also reasonable. What is some extension and new trends, and in particular, in my view, as I worked with these issues? When initially sun and dust storm warning advisory system just focused on forecast and integration observation for prediction. And prediction was just concentration of sun and dust. But for practical purposes and for understanding of mitigation mechanisms, of course, we need to go further. And now it is moving to impact-based assessment and analysis. And it was one of the reasons why WMO starts collaborating with other UN agencies, with UNEP, UNCCD, WHO, etc. For a building. And also moving SDS WAS itself to two main directions, not only for early warning, but also for impact long-term assessment. And for example, for East Asia, by our Japanese team, they built very nice analysis of future projections of climate change and how it will impact on sun and dust storm sources. So here you can see, unfortunately, all scenarios are leading for increasing different level, but by the way, last I think about 5 years in Asia, it was opposite trend. So in general, intensity was a bit lower, but maybe it's just temporal trend. Okay, And as I mentioned, there are several nodes, but NAMI node is more close to your activities. And here it's just early warning for impact-based, as I mentioned, and again for impact on health, aviation, agriculture, economy, and also climate are important to consider. And also for long-term analysis, as I thought. And of course, here, when we are talking about assessment of impact, it is absolutely necessary linked with mitigation strategy. So this is the reason why I always stress what we need to move also to policy framework. And as in this global assessment for sun and dust storm report, what we arranged together with UNEP and UNCCD, many topics were moved to mitigation of sources, what to do and how to make situation better in future and linked to policy issues. And finally, it was step for next development organization of United Nations Coalition for Combating Sun and Dust Storm. And again, for the coalition, no any requirements by nodes, etc., and any organization is able to join. So, Paula, if you didn't connect directly, so you can simply write. And now FAO is still chairman of the this coalition, and they can involve, and you can be involved in one of the working groups. One is adaptation and mitigation, which is the key issue, and forecasting early warning, it's led by WMO, and health and safety led by WHO. Policy and governance, I think it is by UNDP and UNCCD, and also mediation and regional collaboration, which is also important for maybe one of the focus could be on high latitude dust. Okay, and one more new initiative which could be useful for this community during the UNCCD COP16 in Saudi Arabia this autumn, last year autumn now. It was built a new international partnership to enhance early warning systems for dust and sunstorms, they call it. And it is the idea to build kind of platform for helping different regions and different countries for observation, forecasting, and also for solving of problem of combating sun and dust storms. So it is coordinated by director of new organized node now for Gulf countries, not Juman, do you know him? Yes. Okay, so so he's now the coordinator. So right, and now I less involved, so I don't know what kind of rules, but at least now again, thanks for Saudi Arabia and Gulf countries, they provided initial funds for this work, so it is at least working. Okay, and just some published books what Sun and Dust Storm provided. I think this compendium is relatively new and led by UNCCD, and it's
All right. But now you should hear us, correct? Thank you for letting us know. And can you just
Okay, now it's okay. So what I would like to say, first of all, there are many opportunities to increase this GAU observation system by different communities. And for example, as I see from Iceland, some stations could be included as GAU stations. Please think about that. Of course, when GAU, there are special procedure, guidelines, and requirements for observation. So, for example, low-cost sensors, which are very much supported by WMO as additional source of information, but they are not meeting full requirements as full-scale GAU station. So, of course, but from other side, now GAU is extended in different way, and not only in situ stations, because there are global stations, regional stations, and now a new type local stations in situ. But additionally, it could be also using satellite and different type of remote sensing data. There is also Galleon, part of Global Atmosphere Watch program for LiDAR observation, and also ceilometers network is included. And definitely, I think for this network, contribution of this network and high latitude dust observation teams could be really very appreciated. They have also some requirements, but not so strict as the measurement guidelines.
Really, not like Aeronet, for example.
Aeronet provides only column data, but for ceilometers and LiDARs networks now it's also provided some vertical profiling. As I stressed from.
I wanted to say actress. Sorry.
Actress.
Like actress, or because they have very strict requirements.
Yes, for Europe, actress is European network, but Galleon and GAU is global system. Of course, nowadays for greenhouse gases, because Global Atmosphere Watch is a research observation and modeling system. But for operational purposes now, for greenhouse gas, what is called G3 Global Greenhouse Gas Watch system. But it is only for operational purposes. So that's the point. And also, again, taking a look on the Arctic, I think it's not because I'm originally from Soviet Union or Russia, but I think it's stupid to close the door for collaboration. We need to look for scientists. If we are looking for solution for our climate, for our environment, to build artificial borders, it is not suitable and not helping for us. So we need to find some way to collaborate. And of course, for example, when I spoke with new chief of Global Atmosphere Watch, Professor Paolo Lai, he especially asked, please try to convince, try to involve. And when try to do it, they say, but we are not invited to any meetings. Why we will do steps? So from both sides, some steps need to be done. So please think about that. Of course, political issues are also important, but for scientists, we need to look for. As I start my scientific work during Soviet time in YASA, this International Institute for Applied System Analysis in Austria. It was built during terrible time of Cold War as platform where United Nations and Soviet Union scientists tried to work together. It was that time possible to do, but why we are not doing now? I think, please just think. It's
Alexander, can I only ask why is Antarctica omitted? Is not Antarctica interesting for?
well, no, it is. And also for Antarctica, there are several stations. And for aerosol and ozone measurements are especially for upper ozone. For upper ozone, it's very strong system. I don't know why this is not included here, but in general, if you open GOSIS, this Global Atmosphere Watch information system, it is also, you'll find some stations there, but much less. Okay, so that's all what I thought to say.
Would you like to comment on Alexander here in the room?
Questions?
Santiago just had asked a question.
Question.
No.
Yeah, but I don't have.
It says, has Alexander asked ChatGPT what high latitude dust is? The first slide you had the thank to ChatGPT.
Oh yeah. It was idea of Steve Arnold because he was the chairman of our group, and when we prepared this, because for final day of the meeting in Monaco, each round table was allowed to prepare only 3 slides. So we tried to build, and we wrote, of course, many things. Also, thanks for Paula and Oti. But finally, to make it dense, we asked ChatGPT to help.
So, are there any? Are there any questions online or comments on Alexander's overview of high latitude dust in the global networks? It doesn't look like that. So thank you very much. And yeah. So maybe now I would just quickly have a short overview also on the point from the Ice Dust Association. And there are just 3 very short points. I have to go back to my presentation from the day 1. Just to remind you the networks. And maybe I shall borrow the microphone from Alexander instead, this one, right?
Okay.
Thanks. We'll be very quick because we need to get some coffee too. So I will share my screen and just remind you the networks and also the websites where you can find the information. So for the Ice Dust Association, any of you who is not member yet and it's interested in the activities, so you can just contact me on email or just go through the form on the Ice Dust website itself. There is about us, you can find it. And also if you like to add your pictures from high latitude to dust storms in Iceland, we can actually extend it on Facebook into dust storms in the Arctic, because people are then really sending pictures, which is really great citizen science. And then also the Arctic thematic network on high latitude dust is quite active, and we also report a lot of news there, much more than in the ice dust. So you can follow us over there. Now there are still like 14 news missing, but it's also, if you want to join the network, you are very welcome, and feel free to report as soon as you are a member, feel free to report your own activities related to dust or training or networking. So that's actually a great way how to make your research more visible in the context of high latitude dust. So I guess these were the two most important points I wanted to emphasize in terms of getting together. But of course, we will meet us again next year if you are interested in the 10th version of high latitude dust. And I actually wanted to show one more thing, which is the Load Guide Xiao map, because we really are keen on the inputs, like what this map should involve in terms of dust, but also other air pollutants. And you can do that under this info, map info, and then here is the email, and we will get it from you. So that's how you can contact us. And yeah, very welcome, because the user feedback is the most important for us to know what to do. Because you should enjoy the map, right? So it's for the general public and the scientists as well to get the information from the remote areas. Yes, and one more important news, and that's the SDS toolbox. Just Google it here. Because now officially also the high latitude dust is now mentioned there. Not only it's very like well defined toolbox for the low latitudes, starting from the measurements, modeling, but also the mitigation, case studies, source control and measurement impact. So in the category, of course, the mapping, there is the sources for the maps. And I'm sorry, I haven't prepared it, but on one of these monitoring site is already the Icelandic model is already involved. I apologize, I did not prepare the links. And also the association itself. So I think it's a huge step forward. I just cannot find it now, I apologize. Which link it was.
Perhaps you can email the links.
Yeah. I have them on a separate file, but not here. I apologize for that. Research, yeah, I think it's this one, research and networks. Yeah, so there is the North American Alliance, which might be a good idea maybe for the Canadian high latitude dust observer to join. You probably already are part of it. And here we are, ice dust is there, and the thematic network on high latitude dust. So,
and also within the Pan-American node of SDS WAS of the BMO, they have also some focus on Arctic. And Daniel Tong, who is the chairman of the Global Steering Committee, he is leading also this node for America and for Canada. And they combine SDS WAS for sun and dust, and also a new network, new program that also the BMO is now supporting. It's vegetation, fire, smoke, pollution warning advisory system. And for this system, there is a very strong North American node.
Yeah, because they are important source of these.
Also, especially for Arctic. They have special working group for Arctic. And they practically, many scientists who are a member of both sun and dust and vegetation, fire, smoke, pollution are the same. So they are communicate very closely to each other. So maybe good to join.
Yeah, so well, obviously some of us are somewhere, we are kind of spread it in different parts, but it's good to have at least somebody raising the voices of high latitude dust. But yeah, one day it probably will naturally lead
And also
into
one
a
more Serbian
high
positive
latitude
news
dust
that, you know, no.
activity.
Oh, Radenka. Okay. She's chairman of this North American World Station for Pollution.
She's from Serbia originally?
Yes. Slobodan Malshin.
Okay.
So actually, I think if there are no questions on the Ice Dust Association or the related networks from the online audience, we will probably conclude the workshop right now. And so Ote, if you want to say a few words, or shall we just... So thank you very much for being with us these past 2 days. And we are looking forward to the High Latitude Dust Workshop 2026, which will be again around the dates in this week, around the 14th. We will soon let you know. And the location very likely in Iceland, but we still consider maybe could be also elsewhere, but this will be sure within few months, don't worry. Yes, and thank you for your really great contributions. It's so nice to see how all the tools and new methods and new findings are pointing to more and more evidence on the high latitude dust and also the importance of the impacts. Yeah, so there is still Alexander wants to comment. Thank you.
Just to increase a bit information about the activities of network and workshop, maybe to provide an article to Aerosol Association, European or
that's another important actually place where we are, and together with the NOSA, Nordic Aerosol Association. Yeah. Okay, that's a good point. We shall definitely do that, and we can share it with those maybe Nordic Dust Network, which will.
And of course, also SDS was always also welcome to send to Sarah. And
yeah. I will actually just read important message from Anna, who is now the head of the NAME mode of the WMSDS was, and she actually stated that they work on science implementation plan, and there should definitely also be some information on the high latitude dust. So that's probably something we shall work on together. Many assessments pending, I am aware of mine, which is still not finished and will be soon shared. But yes, we are happy to help anyhow to get more in touch, and these workshops are basically why we do that, right? Okay, so thank you very much, and hopefully we will meet us in EGU or any occasion. I'm always happy to meet you in person, and welcome to Iceland next year. So
and to EGU session.
Yeah, EGU session on the atmosphere cryosphere.
Yes, so hope to see you in Vienna at the EGU session where we have the mountain and high latitude dust included in the session. Yeah.
Yes, and then of course the European Aerosol Conference in early September also will be there.
Yeah, in Vienna. Yeah.
Okay. So thank you very much. Goodbye.
Bye. Thank you.
Also, Pablo and Niti, thank you for providing us.
Thank you so much. Both of you, thank you so much.
Pablo, you are really a main engine of this activity. Without you, nothing will happen. And of course,
No,
together with all of you.